Based on what we've just seen, where we can kind of step through arrays with using the pointer, there's some arithmetic we can do. So let's say we have int vals. This time, let's just say this is 4, 7, and 11. Declare a pointer, int pointer. This is just going to be equal to vals. And that's because we have an array. If we just had a regular variable, it would be the ampersand and then the variable name. So let's say pointer is our pointer. So we can just do, let's say we want the second storage location. We could just do pointer plus plus. This adds 1 to it. So this is going to be pointing at 7. This is pointing at the second address. Pointer plus equal 2. So this is, if we dereference what's in that, that's going to be 11. And we could also do pointer minus minus if we want to back up. But once again, be careful not to run off the ends of your array with these things. Pretty much talked about initializing pointers. So initializing is just storing an address to the pointer. So if we have a regular variable, we need to put the ampersand in front of it to get the address. If we have an array, we can just use the name of the array. One thing I want to point out is that you can't mix data types. So for instance, let's say we have a double, and then I'm just going to call this cost. So we have a variable that's a double type. We can't have an integer pointer pointing at that, so we couldn't do this. So int ptr is equal to this. Like, we can't do this. This would result in a compilation error. And the reason why is because so we have a variable that's double type, and then we have a pointer that's expecting to be pointing at an integer. So we can't do that. They have to be the same data type. And that kind of makes sense because depending on your data type, you're going to have different amounts of storage. So it needs to be the same. Let's look at a few more things with pointers. First of all, comparing pointers. So we can use pretty much all of the relational operators we've already been using with pointers. So let's say that we have this. Like, let's say that we have pointer 1 is equal to pointer 2. This is comparing their addresses. So this is comparing addresses. What if we have this? So if pointer 1 is equal to pointer 2. So be really careful with this. A lot of times you'll use something like this and you'll want to compare the values, and it's really easy to accidentally not put the stars, and then you're comparing the memory locations instead of the values, so it's probably always going to be false.